Hello, everyone, and welcome to our interview series where we showcase the incredible success stories of our customers and partners alike. Today, we have a very exciting guest from TetraMem, a company that is revolutionizing the AI memory landscape at the edge. Please join me in welcoming Glenn Gerg, CEO of TetraMem.
Yeah,
Glenn?
thanks so much, Sanjay. You pronounced my surname really, in the correct way. Thank you so much.
Well, thank you for joining us. At the very starters, Glenn, can you tell us and the audience in general a little bit about TetraMem? What's your mission? What the company's all about?
Yeah, absolutely. So started with the name, why we call TetraMem. Tetra means four or fourth. Mem means memory or memristor. So this is kind of like our foundation because we are utilize this so-called fourth fundamental passive device, memristor. Industry also call this RRAM or ReRAM. So basically that's a registered RAM. So basically this is kind of like our foundation. Then through that, we have this, the crossbar array structure. So basically this is very different from today's digital computing logic. Then you made it, through like CPU, GPU, TPU, and other ASIC. But this way is more close to our human brain, which is analog computing.
Sure.
Because we are going to use the RRAM to store this kind of neural net weights and use the, Ohm's law to do the multiplier directly. So one device is one multiplier. Instead of using like digital, you have the hundreds of the gates to do that. And we use this so-called crossbar array structure. So once you're collecting the current, once they finish each of this like a multiplication, that is like a summation or accumulation.
Right.
So using this crossbar array, this is the most nature and the most fit way to do this matrix operation, which accounts from 75 to 99% of all the computation for all cross different neural network.
Interesting. Yeah, I really like this concept with the whole crossbar switch. So, as we see, Glenn, that obviously, AI is everywhere, pervasive, all the way from core to the edge.
Yeah.
You guys are playing on the edge, if you may. What role do you think is TetraMem playing in this blossoming AI ecosystem?
Yeah, we are not just simply looking at the replacement of some of today's digital ASIC. Actually, we are more like an enabler. Because today, if you look at these mobile devices, the glasses, a question will ask like when we can run like a ChatGPT large language model on my phone. Why I can have I can take this glass only, but without a phone, I can go outside, without the network, I can do the meaningful AI things.
Right.
Today, we simply cannot.
Right.
Even the digital chip has gone, like 3 nanometer, 2 nanometer very soon, but they cannot do that.
Right.
It's because we are so limited by the power and efficiency. That's why, basically your throughput is your efficiency times the power budget you have.
Right.
So we are more like the enabler at the edge. Let us to have such like a meaningful AI application through the endpoint, through tiny edge, all the way to the edge.
Yeah, so you kind of touched upon earlier on, AR, VR, the glasses. When you were thinking about starting TetraMem, what was your, so to speak, aha moment that, hey, you know what? There is a unique high-value problem that I need to solve, and thus came the idea of TetraMem. Can you enlighten all of us a little bit?
Yeah.
How did you arrive at this concept,
Yeah.
and what was your inspiration to get this company started?
Yeah, first of all, this is the only thing we are good at and we know how to do, right? I have to choose this. But more importantly, I would say, the architecture-wise for this crossbar array structure for this in-memory computing is not invented by, TetraMem. Even back to 1960s, NASA already started use the in-memory computer to launch this, our rocket to the moon.
Right.
So the concept is not new. Basically, imagine if the memory is the computer, you don't need to move this kind of neural nets. That will cut you a lot of this data movement, which is today, this is the major reason, have such so much energy consumption, so much heat generated because that movement, right? So everybody know this advantage. But the issue is like before, have AI, we don't need so much matrix operation. You don't have an end-to-end system, like this kind of the way. And more importantly, the device is not ready there.
Right.
So, our team originally working on the RRAM devices since like almost 2 decades ago.
Right.
So we have been here for a very long time. And one of our co-founders is Joshua Yang.
I see.
He's a leading research in this field. He used to be professor from UMass. Now he's a professor for USC.
Nice.
So he has about 60 Nature and Science publication.
Sure.
With almost 70,000 citations. So even back to 2013, he think that time even we work at this RRAM as universal memory. try to replace the DRAM and NAND.
Right.
But that time he already think, this device not only in the future as a memory, but more importantly, is a computing device.
Right.
But back to 2013, before the AlphaGo beat Lisa 2 in 2016, we don't have such need, right?
Right.
But after that moment, AI come booming. So 2018, we founded this company. We decide, this is a big enough time. This technology is ready for this. We should go really, working on the commercialization, use this technology. That's why
Awesome.
this is how things come up.
When I'm talking to many customers who are either using application on the edge, particularly when it comes to large language models, one of the feedback I get is, hey, once you're on the edge, you really don't have, quote unquote, the latency or the bandwidth to kind of go to the LLM instance, come on
Yep.
back to get the feedback. So in your view, will TetraMEMS memory be able to hold tiny LLMs at the
Yep.
edge?
Yep.
Can you speak to that a little bit, please?
Yeah. So at this moment, this is kind of like our latest chip, which we just recently have a PI. If camera can see this, is very tiny because it's a 6x6.
Right.
It uses this 22 nanometer. It has a memory size of like a 4 megabyte. So this is definitely cannot run like a large language model.
Right.
But some of the like a
Tiny model.
tiny model, especially for the voice.
Right.
And some of the small computer vision one, we can definitely run this. So basically, this one holds all the neural nets by programming your neural nets into this memory.
Right.
And store there. And bear in mind that the RRAM is non-volatile memory devices. And with the working our foundry partner, actually this one can hold the charge there for like a year to 10 years.
Oh, nice.
Yeah,
Okay.
you don't need a refresh like
Sure,
DRAM.
sure. Yep.
So basically, once your neural net is there, we use the same exactly memory, the device to do the multiplier. Because as I mentioned, you basically utilize this Ohm's law. Your current is your voltage times the conductance. Now your conductance is your neural nets. Your voltage is your input information.
Right.
Then you can, using one device, you can finish this multiplier. And then using this crossbar array structure, you finish the one line to do the summation. That's why the crossbar array structure here, you can finish like a very big matrix.
Much dense, yeah.
Much dense.
Yep.
The multiplication accumulation just like a single step.
Got
it
it,
takes
got
like
it.
only a few hundred clock cycle.
Sure.
But imagine if you even do like a 8 by 8, this kind of matrix multiplication in a digital way, you need like at least few thousand clock cycle and a few million transistor.
Right.
But here is very limited.
Huge, good innovation.
Yeah.
So, Glenn, you've been, I understand the company has been, been run
80
since
years.
2018,
Yeah.
19, young, fairly young, relatively
Yeah.
speaking. What has been your experience for our audience who are in a startup environment? What wisdom will you be able to share? What has been the journey like so far?
Yeah, if I go back, I would say don't start a startup. It's simply just too hard. But lucky, we have a partner like, I have foundry partner, we have EDA tool partner like Synopsys. So far we're doing well. I think the key is like, especially today, with the kind of like a two leading model for this large language model. And I would say the chances if you work on anything on the application level would be very hard because anytime they come with a new feature, a lot of the startup idea could be destroyed, right?
Right.
So now look at the infra, but the infra is really dominated by some of the big players, especially memory, right? Is only by the three top player. So to have some like you must find what's your own strength, right? You cannot say I just choose I want to do the startup because I want to do the startup.
Right.
You must have like a solid stage, foundation. You come with a clear vision, like what is this a complementary part to those like the ecosystem partner, because at the beginning we cannot just say, oh, we are going to replace anybody.
Correct.
So I always say, we never be the NVIDIA killer, we are an NVIDIA painkiller.
Yes.
We help them to as accelerator, potentially to solve this kind of headache, because today using the GPU plus HBM generate a lot of heat. Like latest the GPU we talk about 2,000, 3,000 watts, right? The rack 600 kilowatts.
Right.
So using this the analog in-memory computing enabled analog computing MPU, we can greatly reduce this kind of like a power consumption. So that will be boosting the ecosystem because the pie is simply too big.
Too big.
Yeah.
So help us walk through a little bit, when you were executing the journey and you were implementing the RRAM solution, if you may, what were some of the challenges you encountered and how did you mitigate them That would be very fascinating to learn from you.
Yeah, as I mentioned, the architecture, is easily to be understood, right? So that's why there has quite a number of the in-memory computing company try to achieve that. But if you look at the R1 in-memory computing or multi-level R1 in-memory computing, I think so far we are probably the one of the very, very few. One of the keys, as I mentioned, because the availability of such device. Before us, if you look at it, anybody can produce this multi-level R1 in the fab. The answer is no.
No, right.
Right? There are fewer fabs that produce the macro with the binary memory, but to operate such like R1 devices, the difference is like the R1 devices, compared to the flash, because it cannot scale in.
Yep.
The MRAM, you cannot do the multi-level. PC RAM is, not anybody doing that. FRAM is too premature.
Correct.
So R1 is by far the best, candidate in my perspective to do this, in-memory computing because it's non-volatile, multi-level, good endurance, good retention, and totally compatible with the CMOS logic with only 2 masks added for this.
Got it.
The cost.
So there's not a necessary process to be brought up for this particular memory class, etc.
Yeah, but the challenge is like to control such device, because the R1 device is not a simply a solid state or electronics device. Actually, it's electric thermal chemistry devices. If you're understanding how the R1 operation, then you probably understand what is the challenge to bring this, because to control such like the filament, which is like the oxygen ion vacancy mainly, with mixed with some of the ions. So basically, to control such like a filament as a modulate your resistance you want, it's a very complex process. It's beyond you're out of foundry, you're according to the foundry, the operating safety room, you can have such like a good operation like a transistor.
Sure.
But R1, you need a lot of know-how how do you control this from the the forming, the set, reset, and so on.
Yep.
So basically, this is need a lot of the understanding for the device itself.
Got it.
That's the most challenging part, and also this is our very big foundation on top of the collaborate with the foundry partner to have such a device and such a wafer build. But more importantly, how do you operate them? How do you operate your neural net according to this kind of things? That's why we are very proudly to say Tetraman is probably the world. One of the pioneer for this so-called 6-dimension co-design co-optimization, because we're optimizing all the way from the material, process integration, device, IC design, our firmware, and application level. So basically, they have a lot of the interaction for each other. It's a very big know-how in the mode.
Thank you for the explanation on the device and the properties of RAM.
Yeah.
But you also talked about the IC design element.
Yeah.
Can you help us and our audience understand some of the technical hurdles, challenges you encountered during the design process of this RAM solution, and how did you overcome them?
Yeah, that's a great question, because the true value for this analog in-memory computing is this cross-barrier and the peripheral driving circuit. So the rest we just leverage the commodity IP core, for example, RISC or ARM core, the I/O, and so on. But to design such like a core is first of all is a mixed signal.
Right.
Secondly, for the multi-level R1, nobody working this before.
Right.
We are kind of like a pioneer to really work at. Yeah. So this is a lot of the, I would say, because your quadrant of knowledge is like if you know is best. You don't know, you can learn. You don't know is also good. But there's a lot of the things for this particular problem. You see, you don't know until you surface this kind of problem.
Right.
For example, to dealing this kind of like the RC delay or this particle resistance across such a big crossbar, that is a lot of the headache you need to have design. And secondly, because when we're dealing with a very big crossbar with the multi-level R1, your TI, ADC, this kind of design, the range, everything will be very challenging.
Right.
That's why, we needed to have the team really workly, between our ADC designer, TIA designer, our cross-barrier designer, our digital designer as a team.
Right.
The teamwork and the coordination is very important.
Sure.
That's why we need to find some like a very good platform. So this lucky like we work with Synopsys because your cloud is really help us to do that. Because otherwise we have a team across mainly in the US, but we have some small team in Singapore doing some kind of like a digital design. But we need to work as a team. In the past, if you're doing the server way, it's a very challenge. But using the cloud actually help us a lot and accelerate this progress.
Great. I mean, I'm so thankful, and we appreciate that you are working on the cloud environment that Synopsys offers. Can you also, you talked about, engineers being geographically dispersed, having cloud helping them to all come together.
Yeah.
What other elements of your challenges that you had during the design process, whether it is teams or collaboration, that Synopsys helped you with tools or delivery like cloud? Can you educate our audience for that a little bit, please?
Yeah, there is a lot of the cloud provider. There's several EDA tool provider, but the Synopsys is the one can put the two together. We have like a one-stop solution. That saves us a lot of headache. And use the cloud and use Synopsys cloud service. Actually, we have a lot of elasticity because sometimes and time zone coordination as well.
Yep.
So we really can work globally as a team together, can seamlessly, this team finished this block and they just write down some pass down in the Jira and so on. Then they can, next team work on, they can seamlessly work on right after that. So that actually is a very powerful and useful. And another perspective, I would say we benefit a lot from the partnership with the Synopsys. Like you guys not only just a cloud EDA tool, but you also has a lot of IP.
Right.
Like recently, we use a lot of IP license actually from Synopsys. Like we did this kind of like a VPDD, this kind of the verification IP. And I think very recently we started working with you guys for like a MIPI as well.
Got it.
So in the future, maybe like a
Expand
more. So basically, I think Synopsys is one of the very few vendor you can have like this
All of it
one-stop,
together,
one
one-stop
stop,
shop.
and seamlessly coordinated internally.
We're glad to partner with you. By the way, congratulations. I heard that you recently announced that you received the silicon of MLX 200.
Yeah.
And you're now ready for evaluation.
Yeah.
Oh, great. That's the device we're looking at.
That's this
and
one.
so you want to share more information with our partners and customers alike that you're ready for evaluation. This will be your time.
Yeah, we tip up this one last November, and this is basically based on the Synopsys tool, work with a lot.
Right.
And this is the first multi-level R1 SoC in the world based on the 22 nanometer. I would say even the first production in the different technology node, right? So this one, the target is for this all this kind of audio application and a small video. So we already get a lot of the engagement and actively collaborated with some of our leading customer in terms of like a source like a MEMS speakerphone, MEMS microphone. So this one can do like denoising, can do like a keyword spotting, can do the voice ID and so on. And also we work with some of the computer vision companies. They can put this one into their CMOS image sensor.
Right.
It becomes the smart sensor. So basically the 22 nanometer is very ideal for this kind of the endpoint and the tiny edge and the sensor and IoT application. Because the 22 nanometer is the kind of last generation using the planar MOSFET.
Planar MOSFET, correct.
So in terms of like a per transistor cost is the best.
Right.
So you will see a lot of microcontroller, a lot of low end, this kind of processor will be based on this technology. So we'll be stay there for a while. So while we just tip up this, the MX200, actually, the pipeline already have the next version, the MX200M, which is standard for memory enhancement.
Sure.
We have the 200-201, which is a very tiny version of this one. Basically, the packaging size will be less than 1.8 times 1.7.
Nice.
It can co-package it with the microphone.
Sure.
So this is in the pipeline. But in the meantime, I will be more excited, because 22 nanometer is just our first wave for the production for the tiny end, endpoint and the tiny edge.
Right.
But the next 12 nanometer will be high performance edge because that one will boost the energy efficiency even further because the 12 nanometer will be the generation they start using the FinFET.
Right.
As we know the FinFET, because the device architecture, it can have a much driver capability, very good, off-to-on ratio and so on, and a very clean off current. So basically, the 12 nanometer will boost our performance to the next level.
Right.
So we can achieve like 100 TOPS per watt efficiency based on the 12 nanometer.
I mean, the whole world is this explosion of AI everywhere, which fundamentally means more and more silicon is going to be in every device that we see in our daily lives. So from as a founder, CEO of this company, and obviously keeping tabs on what's happening with the AI technology evolution, so to speak. So I know you talked about moving from 22 down to 12 and below, but in general, I mean, from your offering, where do you see TetraMem playing a big role in this AI revolution, if I may, going forward?
Yeah, that's a very great question. We, of course, we have the very bold claim and the very great vision. So I would say, to me, the AI has three waves. The first wave, just the AI for something useful, like a vibe coding, some of the agent and so on. The wave 2 will be the AI for the the vertical integration and the doing kind of like the real great work and embodied and so on.
Right.
The wave 3 will be AI for new science, like new physics, new bio, new health, new math. So we are actually, I think we are just in the middle of the wave 1.
Got it.
For sure, you will see some kind of like the the hyper, some of the inflation, some of the bubble. But overall, I think if you ask anybody want to use more AI.
Right.
Today, the reason they don't use so much AI is only because of the cost.
Cost, right.
Imagine, if you use the Anthropic, the latest model, you have $20 per month, unlimited use.
Right.
I believe everybody will use that crazily,
That's true.
right?
Yeah, it's a cost element.
Yeah, it's cost element. Yeah. So what we view ourselves in this is like, as AI moving from the computing centric to the memory centric, actually the in-memory computing will be even more important because it is not only to solve a lot of the supplier shortage from the IDM.
Right.
And more importantly, we need to have this kind of energy efficiency. Otherwise, US and worldwide, they cannot supply so much the electricity for this kind of the data center. Because today, how many people really use AI, right? How many people intensely use AI? This is small fraction of our population compared to the smartphone.
Right.
So the enabler to have this very low cost AI is the key. But to lower this kind of cost, to have efficiency is the key of the key. Otherwise, you need to have this huge gigawatt data center, not a cost like 500 billion to build that. But more importantly, we simply don't have so much water and electricity.
Exactly. Power and electricity, the grid cannot produce enough power.
Yeah. So our mission is like to basically using the analog in-memory computing, kind of like try to catch up with our human brain efficiency, which is only 20 to 30 watt.
Right.
So we can greatly, increase, kind of like promote use of the AI. Yeah.
Great. I mean, this has been quite informative, Glenn. So I know we are at the top of the hour here.
Yeah.
Any advice as final words you want to offer to our audience, particularly those aspiring entrepreneurs who want to start their own chip design journey? What would you tell them?
Yeah, for the, as I said, the startup is really not easy. So if you really want to start the startup, have the good technology foundation, has a good idea, make sure this is a true customer need, not like
Imagined need versus real need.
Yeah, and also you need to really find a good partner with like an EDA tool like a Synopsys, right? And lastly, for the talent, if you think all this criteria I mentioned is not fit to you, then join Tetraman.
Glenn, thank you so much for your time. Enjoyed the conversation.
Sanjay,
Thank you. And thank you to our audience for joining us today. Stay tuned for more inspiring stories from our customers. Until next time.